Hey everyone, welcome back to TK's Tech Talk. Today I'm going to be doing another PC build based on a ITX case with an ITX motherboard and AMD Ryzen 5 5600G. So some of you may or may not have already seen my Intel 12900K build with the Z690 motherboard, and this is going to be a much more basic and budget friendly build with the Ryzen 5 5600G as it has a built-in graphics card. So let me just talk about all of the components first, and I'll try and make it as detailed as possible to make it easier for first-time builders to follow and understand how to go about building a PC. And if I make any mistakes, feel free to let me know so that I can correct my video as well. So on the left here I have the Thermaltake Core V1 Mini ITX case. So this case I've done an unboxing and overview video already. Feel free to check that out if you want to have more details about the case. But in short, this case supports an ITX motherboard, and that's why I have the ITX motherboard here. And also it has space for an ATX power supply. Now what does that mean? Well, usually smaller cases have space for small form factor power supplies. This case, because it's slightly bigger and Thermaltake have been nice to us, they've decided to allow us to have a full power supply support. So on the right here you can see I've actually got an EVGA 600 watt 80 plus power supply. So while we're talking about that power supply, I'm using a 600 watt power supply. It's probably way more than I need for a build like this, but the reason I'm using it is purely because of price. So when we look at budget, we care about price, and if the price to performance is really what we want to try and achieve. So this has a 80 plus rating, and you can also get things like an 80 plus bronze, silver, gold, platinum, and I think titanium. And all that means is how efficient the power supply is. So 80 plus white is fairly basic, but at least it's somewhere to start. You do get power supplies without an 80 plus rating, and that will mean that they're not so efficient and they would probably use a bit more electricity than you would like. So that's the case in the power supply out the way, and so let's talk about the main components here. So we have the X570i Aorus Pro Wi-Fi. So this is a AMD motherboard, and it is based off, let me just move the RAM for a second. I'm not sure if it says it here, but this is there it is, socket AM4. Now that is the socket on the motherboard which allows a processor like this one to fit inside. So you have to make sure that when you're buying the processor and the motherboard, you are buying the correct socket motherboard. I'm just going to make sure it's on here so you can actually just about see it there. It says here AM4, right? So it says on the processor box AM4, it says on the motherboard box here AM4. So that means we know that this processor will have the pins that will correspond to the AM4 motherboard. Another thing I want to mention is some of you might be watching this video going, if this is a budget build, that is not a budget chipset. And you're right. Now what happens is, I would say there's a budget build and then there's a budget ITX build. And what you will notice a lot of the time is that ITX builds are actually more expensive than a normal micro ATX or ATX build. And that's because ITX components, maybe there's not as many people building ITX systems. So I'm guessing the price, it's just a guess, I'm guessing the price of ITX components is higher. Now, then why did I buy an X570? So let's first talk about what does X570 mean. X570 is the chipset. So for AM4, we have multiple chipsets. We have the A520, the A320, the B450, the B550, and the highest one is the X570S, but the X570S and the X570 are more or less the same, with the exception of having the heat sink without a fan. So I've got another video. I'm going to talk about this motherboard in detail in another unboxing video. We're not going to do all of that here. I will mention some key features as we go through the build, but please feel free to check that video out. It's already on the channel. So the X570, now I've said it's the highest, so why did I buy it? Well, this is actually a 3-year-old board, so it's not a new board, and you can get newer chipset boards like the B550 and the B550 ITX boards. So I paid around £135 for this one. I think it's around 130 right now on Amazon, well, at least at the time of recording. And if you look for a B550 board, it costs around the same or more at the moment than this board. And there are some additional features that you will get on the X570 over the B550. But in short, I chose this board. There was an A520 ITX as well, but I chose this board because it still has features that are future-proof, and the entire system would only cost you about £30 more if you opt for the X570 over the A520, right? The most important thing here to remember is that I'm using this Ryzen 5 5600G, which has a built-in graphics card, so I don't need to buy an additional graphics card. And because I'm using a Ryzen 5 and this is the 5000 series, before this was the 3000 series, and we're around the corner from the 7000 series, they all work, and this is the massive benefit of AMD, they all work with the AM4 socket. So that's that said, and this is a Ryzen 5 5600G with 6 cores, 12 threads, and I believe it's a Vega 7 graphics card. And you can also get another one, which is the 5700G, very similar to this, which also has a graphics card built in. One very important point to note here is that usually most of the AMD processors until today on AM4 do not have a graphics card built in. I believe the only ones that do are the ones that are suffixed with a G. So 5600G, 5700G, 4600G from the Ryzen 4000 series, 2200G I think might have had a graphics card, 3200G. So all the ones with the G are typically the ones with graphics card, and they're actually much harder to find, the older models. So this was on sale for around £130 on Prime Day. So again, another great deal considering you get the graphics card built in. If you build an Intel PC, however, most of the processors do have graphics cards, except if they have an F at the end of the model number. So for example, if you're buying an Intel i7 12700F, that will not have a GPU built in. If you buy a 12700 or 12700K without the F, it will have a graphics card built in. So that's just a quick overview about the processor, motherboard, and the socket. So for example, with the Intel, if you're buying a LGA 1700 motherboard, but make sure you buy LGA 1700 CPU. Feel free to check out my build of the 12900K with the Z690 LGA 1700 motherboard. So another thing I want to mention while we're still on the CPU is that this CPU does have a cooler built in, not built in, it has a cooler included with the box. And it's good for builds like this because, you know, you don't need to, especially again, budget is the thing here, budget oriented build. You've already got a fan. The fan could typically cost you around £20 as a minimum for a reasonable quality fan. And you know, you may notice that the processor with this built-in fan, depending on your workload, remember, if you're just going to use it for office work, this is fine. If you're going to use it for gaming, in most cases I guess it will be fine, but the processor will run hotter, and maybe that will cause it to throttle. So when the processor goes over a thermal design limit, like for example, if this processor is rated at 90 watts and it hits the 90 watts and gets too hot, then it will slow down a little bit to compensate for that, but the performance will be slightly degraded at the same time. So for that reason, I've chosen this H410R white edition. Now, can you see the text there? Maybe I should just bring this down a touch. That's better. So the H410R, what's important for my build about this fan and cooler is this case, right? So the issue is that if we're building in an ITX case, we have to be much more careful about clearances for our CPU coolers. This is true for any size case, but especially with ITX builds, because even the standard 120mm fans that you normally get on a cooler, they have bigger heat sinks, and then obviously they become taller. We have to make sure that we don't exceed the height limit of this case for the cooler. Now, from the motherboard tray up to the top of the case, it's around 140mm clearance is what they have stated. So this cooler actually has a height of So the dimensions are just there. I'm not sure if you can read it, but it basically says 92 by 92 by 20. That's the fan. The total package height, there we go, dimensions 136 millimeters. So we're just within the limits for this case. So you can find all this information, you know, when you're searching, if you just do a quick Google search, check for the case you're looking for. So in this case, Thermaltake Core V1, find the manufacturer website, go to the specifications, and you would be able to find what is the maximum cooler height. Then you can go and find your cooler website and do the same thing to make sure that the maximum dimension of the cooler, which here is 136, does not exceed what the manufacturer for the case states should be the maximum height for the cooler. Right, so we've talked about ITX case, ITX motherboard. So forgot to mention that you can get M-ATX boards, which are slightly bigger, and then you can get ATX boards, which are full-size motherboards. Then you can get eATX, which are, I think, extended ATX. So they're very big boards. So make sure that when you're buying your motherboard, it will fit your case. So if you're buying an ITX case, make sure you buy an ITX motherboard. You can put an ITX motherboard in a much bigger case, so that doesn't matter. You can still buy a good price board to stick inside a bigger case, especially if you don't need the additional slots and features of the bigger board. So we'll have a look at that as we go into building the PC. And the last couple of components, and probably two of the most important components in addition to the CPU, are the SSD and the RAM. So what do I have here for the SSD and the RAM? So I have chosen, I've actually stolen this from my main build. I've got two sticks of 16 gigabytes DDR4 3200 CL16 RAM. And some of you might be sitting there thinking, or standing, if you're standing, thinking, what does all of that mean? So basically, the first thing we need to make sure is that our processor and motherboard are getting the correct RAM, because they will have a slot which can be used for your RAM. Now this DDR4 RAM is the current RAM, and there is DDR5 as well, and most of the motherboards on the market today, at least for the previous generation, especially X570 and all AMD boards on the market at the moment until AM5 comes out, is all DDR4. So if you're buying an AMD board, you just buy DDR4. That's the easy bit. If you're buying an Intel board and you wish to buy a DDR4 motherboard, then make sure you buy DDR4 RAM, because the 12th gen does support DDR5, but DDR5 is more expensive. So if you don't want to pay the extra money for performance that you may not realize you need or notice, you can still buy DDR4 for around 50 to 100% cheaper depending on which brand and configuration you buy. So, you know, make sure you buy the correct RAM for your system. So again, for AM4, for now, it's all DDR4. Then the 3200 is the speed, so 3200 megahertz. I think some RAM kits say mega transfers, MT per second, and this is megahertz. So 3200 megahertz is the speed of this one, and it's an average kit. You know, it's definitely better than buying a 2666 or 3000 or something like that. So I would recommend look for a good price 3200. I do believe that it has the best price performance value. 3600 you can get at good deals as well sometimes, but essentially the 3200 is the speed of the RAM, right? Just think of that, the higher the number, the faster the RAM. It's not completely like that, but in general it should be like that. And then you have CL16, that is the latency, so, or C16 you might see it written as, and the lower the latency, the better it is. And now you will notice that a lot of RAM in the budget, especially in the budget series, will have 3200 at C16 and 3600 at C18. Now people argue that they both perform around the same because you've got higher latency on the 3600, but the 3200 has a faster latency. So in some cases you'd see better performance with the 3200, in some cases you'd see better performance with the 3600, and yeah, this is too much. This is a very detailed topic to go into right now, but I would say safest bet 3200 C16 or 3600 C18, both should be okay, right? So I've stolen these from my main PC, and then let's quickly move on to the SSD. And now I know SN850, as some of you may know, is probably not the cheapest drive you can buy. Now it's not, but so ignore the fact that this is not a budget drive for now. The reason I'm using this drive right now is the only one I had easy access to. I stole it from my PS5. It's much easier to remove a drive from the PS5 than it is from your PC. But ideally, I would personally have gone with something like the 970 Evo Plus or the Western Digital Black SN750. Those are PCIe Gen 3 drives. And you might be saying, hold on a minute, what does that mean? Right, so if you have a look on here, it says Gen 4, 7,000 megabytes per second. The motherboard also says PCIe 4.0 ready. I hope you can read that. Let me just zoom in a little bit so you can see it. At least I hope you can see it. There it is. Let's keep it zoomed in here for now. So that means that because this motherboard can support PCIe 4 and this SSD is PCIe 4, I will get 7,000 megabytes per second. And now there's just something I want to mention. This processor does not support PCIe Gen 4. So if you buy a Ryzen 5 5600 without the graphics card built in, you will get PCIe 4 support. If you buy the Ryzen 5 5600G, you will not get PCIe 4 support. However, to my understanding, and we'll test this, is if you're using a PCIe 4 graphics card, it will not work. It would work at PCIe 3 with this processor, right? Now with the X570 chipset, X570, some of the chipset will also allow PCIe 4 independent of the CPU, at least it should. So this motherboard actually has slot for 2 of these SSDs. Now there's one problem with this SSD right now. When we start doing the build, I might have to swap this drive out because the primary slot on this motherboard has a heatsink on top of it. This drive comes pre-installed with a heatsink on top of it. So there's a problem here, because what this means is I may not be able to put this under that heatsink. However, there is a second slot on the X570i on the back of the motherboard. So hopefully, assuming the case, and let me just have a quick look at that, I believe the case may have a cutout as well at the bottom of the motherboard plate, which we'll see, and that should have clearance for this SSD. So there's a good test to do, might as well do it while we're building it. So I think that's all of the components we've talked about now. So we've got the SSD, the RAM, the processor, motherboard, case, you know, and all the things you need to think about when you're building a PC. Now, if you're struggling to decide what components to buy or need some help, you know, please feel free to ask me in the comment section. I will try and help you if I can. And there is another great website, and I'm sure there's many more like it. PC Part Picker will to some extent give you compatibility of motherboard, RAM, processor and things like that. So like I said, I've already done an unboxing of that, of the X570i. Feel free to check that video out. I did a WD Black, I think, install on the PS5, so have a look at that video if you want. And like I said, the case video is already done. We'll just unbox the power supply as we go along in this one, and the processor as well, and the cooler, so we'll get to see that for the first time. So one more quick thing to mention before we start the build, and I know we might run into a problem with this straight away. This motherboard looks like it must have been lying around for a while. Maybe that's why they've reduced the price to get rid of them. But one thing interesting about this motherboard, it says Ryzen 3000 desktop ready, but my processor is a Ryzen 5000. So it's quite possible we're going to need a BIOS update for this build. So thankfully this motherboard does have a BIOS flashback option. What does that mean? Let me see if it's here quickly, I'll show it to you. But basically what that means is that we will be able to use a USB flash drive to update the BIOS. Should be mentioned here somewhere. Okay, I don't see it there. But we should be able to, oh, there it is. Q Flash Plus or something, I'm guessing that's what it's called. So it's BIOS flashback. We should be able to flash the BIOS without having a supported processor. Now that is very handy because I don't have another Ryzen 3000 CPU. I did have one, but it's gone now, to update that BIOS. With all of that said, let's start the build. Okay, so let's start with the case and the power supply. So let me just get the case out of the way for a moment, and I'm just going to quickly unbox the power supply for the first time with the trusty kitchen knife. Forgot to do the introduction today, but let's just open this up. And the reason I want to get this opened up is because I think it's inevitable that I'm going to have to upgrade that BIOS and the motherboard, so I will need access to a power supply. But what I will do, I'll get this opened up, we'll open up the case. I'm not going to install the power supply into the case just now. Why am I having a problem opening this? There we go. Get all that plastic off. And oh, another sticker. Let's get rid of that as well. So here's some warranty and bedtime reading information. So you can see this power supply does come in 500, 600 and 700 watt configurations. I think there was a great deal at the moment on a 700 watt power supply as well. And then we have the power supply itself, and we have a power cord. So let's get rid of that box for now. Almost forgot the sticker, screws. There were also screws included inside. So with UK power lead, let's just open this up and see what we have inside. It's a nice, simple black power supply, and an important thing to know here is that this is not a modular power supply. What does modular power supply mean? It means that all of these cables will have ports to connect wherever you need, rather than having everything connected. Now obviously this is the budget power supply, so it's going to be cost orientated, and we have a 600 logo there to remind us that this is the 600 watt version. And then we have some power information. I'm not going to bore you with it too much, but it tells you how much power each rail. So we have a 12 volt, a 3 volt and a 5 volt rail, the 12 volt being the most important one for your graphics cards and for most major components like the CPU. So this is a 600 watt power supply. So that's the power supply over and done with. And just a couple of things I want to mention here. So I'm just going to take these cables out, get rid of this tie. Is that we have this 24 pin connector, but it's labeled as what? I actually like that about this, because I realized usually you forget, is it 20, is it 24 with this? Anyway, so this is a 20 pin connector, and if you attach this thing, which just literally clips on, something like that, okay, that becomes your 24 pin connector. So most motherboards these days have 24 pin connectors for the motherboard, and then they will also have a 4-pin or 8-pin CPU connector. So in this case we have two 4-pin connectors, so you would get motherboards with 4-pin connectors, with 8-pin connectors, maybe two 4-pin connectors. So there should be another one here somewhere. Should be another one somewhere. Okay, so this one only has one, maybe because it's a 600 watt power supply. I think that makes sense now. So it only has one 8-pin power connector, which is fine for the motherboard that we're using. And then we also have a graphics card connector. And how many graphics cards connectors do we have? Just the one. Right, again, this is not going to be a big deal for our build, because it's going to have no graphics card anyway. So we've got a spare where it's a 6-pin or an 8-pin, right? 6-pin, 8-pin. So that will depend on which card you're using. And then we have SATA connectors for your hard drives or SATA SSD. So we've got 3 on that one. And then we have 3 Molex connectors for the old style hard drives. And there are some things nowadays like fan controllers and things like that which do use them. And you also have an old school floppy drive power connector, and again this is used for fan controllers and things like that these days, so it's not a completely wasted port. Oh sorry, on the PCIe there was actually a second one, I didn't notice that. So there's 2 PCIe 8-pin connectors, which makes sense. I was wondering why there was one and I didn't realize the other one was hanging off it. And we already talked about the CPU connector, and then we have the SATA connector. So there's 2 SATA connectors, so there's 6 SATA connectors in total for this power supply, and then we have 6 there, Molex and graphics card and CPU. Right, that's the power supply done. And let's open up the case. And like I said, if you would like a more detailed information about this case, I do have another video, but for now we're just going to open it up, get it ready for the build. So we have these basic thumb screws. They literally just open up. Okay, and that's that done. And then we're going to open up this side as well. Just going to open all the panels so that I have easy access to the case. And this case is really good because, you know, it came with thumb screws. It's a decent case to work in. It doesn't have glass, it's got plastic, it's fine, it's not a big deal. And so here our power supply is going to go here, the motherboard backplate is going to go right there. Why isn't that sliding off? Let's try again. Stuck somewhere, is it? Oh, there we go, just pushed it out. Right, so that's that done, and inside you're going to see all of these cables and wire ties and whatnot. Let's just take all of that off. Try and do this quickly because I don't want to bore you with these things, because obviously I think it's still good to see. So we have lots of screws and things inside, and then we have all of the connectors. So these cables are going to have to be managed somehow, all of these cables. We'll talk about what each of these cables is later, but basically one of them is the fan connector, one of them is for the USB connector, one is the HD audio connector for the front panel audio, and then we have our favorite pins for the power reset, LEDs, things like that. So that's the case also out of the way. So I'm just going to chuck all of that at the bottom for now. And one thing I was talking about earlier, there is a hole there on the motherboard plate, you see? So that will allow, hopefully, for our SSD to go in without any issues at all. And let's get this out of the way and get the motherboard back. So usually what I like to do is open up the motherboard, put the processor on, but I'm going to open the motherboard now because I'm actually going to do the BIOS flashback. And what I've decided to do, so I've got another unboxing video, feel free to check it out. But what I've decided to do is to do the BIOS flashback, because it looks like, according to this serial number, I have probably got a motherboard. I'm not sure if any of them come with it anyway, but this motherboard will need to be updated to support my processor. Now I've seen a lot of people do it, you know, with and without the CPU installed, but I don't want to put all the components on and then have to worry about that. So just a quick look at the board. Okay, so you've got the RAM slots, CPU slot, this is the AM4 socket. We've got the PCIe Express graphics card slot, and this is what I was talking about. On the ITX board, we just have one PCIe connector. With the M8TX and ATX, they expand more this way, you get more connections. And then we have that one 8-pin power connector for the CPU there, the 24-pin connector there for the motherboard. So the power supply is obviously going to be fine with that. And on the back I/O, we can see lots of USB ports, and there is my BIOS flashback port right there. And we've got the display port, HDMI and HDMI, so this will be useful for our onboard graphics card. We have a USB Type-C port, a Gigabyte LAN port, and Wi-Fi as well. So this motherboard also has Wi-Fi, and then it has that M.2 slot I was talking about at the back, which we're going to depend on. So let me get this BIOS updated, and I will have a separate video showing you how to update the BIOS if you do end up buying this motherboard and using it with the Ryzen 5000 series, and then we'll continue with the build. Okay, so the motherboard BIOS has been updated. I'm hoping it works, but you feel free to check out that video if you want to see how that's done. And what we're going to do now is, what I like to do first is either install the RAM or the CPU first into the motherboard before we start putting the motherboard into the case. So usually there's a SSD slot under this. We would utilize that for the M.2 SSD. We have the 2 RAM slots, which we're going to put in the RAM I showed earlier. So we're going to start with the CPU. So let's unbox the CPU first. So the trusty kitchen knife is back again, making 2 appearances in one day. So let's open up the seal here and get this processor out of the box. So the first thing we see on the left hand side here is the processor, and that, I believe, is inside this plastic sleeve. Lost the camera there, apologies for that. I'll just open that up, and there is the processor. And then inside the box, like I explained earlier, we do have this raised cooler, as you can see in there. Let's open that up. And this is a standard AMD cooler. So we're not going to be using that, like I said. We're hoping the cooler I've chosen would fit, would have the correct RAM clearance. We will talk about RAM clearance when we actually come to putting it in. But I'm just going to get rid of this box for now, and let's concentrate on putting that CPU onto the motherboard. So here's our motherboard, and here is our CPU. So what you have to remember now when putting the CPU inside is that you will see that there is a pin, or rather a golden triangle there on the bottom of the socket, of the CPU, sorry. And basically what we need to do is line this golden triangle with a triangle which is on the motherboard CPU socket. I think I lost the mic earlier, so if the audio is low, I apologize for that. So I've managed to get zoomed in a little bit more, and we can see the triangle is literally right there, and we're going to line it up with this triangle on the CPU. So first thing is we have the lever for the CPU. Now this process will be slightly different on Intel motherboards, because as you can see, there are no pins here. The pins are actually on the bottom of the CPU, right? On the Intel setup, you get the pins on the motherboard, and that is I think going to become making its way to AMD as well now on AM5. So we can just check that one more time, make sure that we're lining up the triangle, and we're going to put it down like that, and it should literally just, when you put it in the right place, it will just slip in like that. You can move it around, it's not moving, right? And then once you're confident that's in properly, you can just pull the lever back down, and the CPU should now be secured into place. So that's it, that was the easy bit. CPU is done. And the next thing we can now do is install the RAM. So here are my RAM sticks, and I think I might have mentioned earlier, what I would highly recommend is making sure, go to the motherboard website, make sure that the RAM you're buying is supported by the motherboard. I mean, it is not, it's called a qualified vendor list, so it's RAM that they may have tested. It's not necessarily a definitive guide to what RAM your motherboard can support, but it will be a good idea to check that out before you install it. So one thing you have to know is, if I open one of these up, in the middle of the RAM there is a notch right there. Okay, so right there's a notch. So we have to line up that notch with this notch here on the motherboard, and make sure you've opened these clips. You might have seen me doing that earlier. Make sure these are all open. Some of them do have fixed on one side, and then we will literally just slide the RAM inside that slot. So we need to make sure, you can just have a quick measure like this to find out which side, because one side is short and one side is long, right? So we can see that that's about right. So if I now slide this in here, make sure it's lined up properly, slide it in, and then apply even pressure on both sides, top and bottom, and eventually you will hear a click. There you go, that's the first one done. So we'll do exactly the same for the second one, and now we can cheat for the second one because we know they're both the same DIMMs, so it's going to go that way. They both say HyperX, and there we go. So the RAM and the CPU are now in. Right, so let's get the SSD installed. So if you remember, we had the SN850 from WD, and this is the PCIe 4 SSD, and it has a heatsink pre-installed. I wouldn't recommend trying to rip that heatsink off. But basically what we're going to do is we're not going to install it in the front slot under this. You can have a look at this slot in my other video to see how it's all set up. But for now, I'm going to put this drive at the back of the motherboard because I want to see how it does for clearances. So if you have two slots like this motherboard does, the X570 has two PCIe Gen 4 slots. Both can run at the full 7,000 megabytes per second. So here you'll see a standoff with a screw. So we're just going to remove the screw. Okay, Okay, and I have had issues in the past where the standoff and the screw are so tight that I couldn't get them out. But thankfully that's not the case today. And then you can just use a plier to, you know, separate them, but at least we don't have to do that extra headache here today. So it looks like we're in there, in line at least. So I think I've got the wrong screwdriver for this, but let's just try anyway. There we go. And we literally just screw it down like that, and then we close it in a little bit there, and there you go. That actually looks really nice. Now, the only thing I'm concerned about is this depth here. Is it going to interfere with the power supply? If it does, I'd have to change the drive, but these are all things you experience when building a PC, and we have to accept it. So let's leave it in there for now. Okay, so now we're going to move on to the CPU cooler, as we saw before. Oops, upside down. The H410R white edition. Now, I just realized something. I put the SSD in, but I'm going to have to take it back out. You see, this is why it's important to plan what you're building, because now I'm going to put the heatsink and fan on now, but this it's not flat anymore. So let's remove the SSD. Right, the drive is out, so let's unbox this cooler. Is that okay? Maybe we need to zoom out just a touch. So let's just unbox this cooler. Trusty kitchen knife again. Third time in the same day. Okay, let's just open this up. Is that open? It's open. And let's see what we get inside. So I haven't opened one of these coolers myself before, so we can have a look. Oh, oopsie daisy. Okay, there's some screws and brackets in here for different types of CPU. And there we have the heatsink. We can just see inside there. So let's get that out. There we go. And there's some bedtime reading inside in case anybody cares about that. But then again, might not be bedtime reading today. I think I might actually need some help to install this cooler, because the issue with building PCs and using different coolers is they all have different installation mechanisms. Now, one thing that I want to check, and we might have to remove some more components, maybe the RAM, because I just realized we haven't thought about something. Now, remember I told you about the clearance from the case? We also need to worry about RAM clearance with the CPU cooler. So let's just leave it all as it is for now, and let's just see how that will go on. And that actually looks like it's going to fit perfectly. Can you see there's space there at the front for the RAM? So that looks good. And we're more or less at the middle of the CPU. So that looks about right. So worst case scenario, you might just be touching the RAM. Absolute worst case scenario, but it looks like we'll be fine. Now, one thing is to point out here is that it's not necessary that all coolers that you get will sit in this orientation. Some may have brackets that are mounted in this orientation, and if that's the case, you're gonna have to think about your graphics card there, right? Now, why this orientation is good is because we're blowing the hot air straight out of the system. So it's something to think about. It's more effective for cooling. But for now, let's concentrate on getting this onto the motherboard. Okay, so I've taken all of the parts out of the bag, and I've got my faithful bedtime reading here, which is going to tell us what we need to do, right? So let's just adjust that a little bit so you can see everything. Then that should be good. So first step is we need to remove the fan. So I guess we just, there we go. The edges are a bit sharp, so be careful with that, right? So we've removed the fan. The next step is to apply paste. I think we can do that later on. That's not important right now. So we need the right brackets. So AM4 brackets are going to require the straight ones. So we've got some bent ones, we've got some straight ones, and the picture looks like the AMD ones are straight. So let's get rid of these two for now. And then, oh, we've also got some CPU paste there, it's handy. So this plastic bracket also says AMD, so it looks like we're going to need that at some point. So right now, let's get the heatsink And we're back on this step here. I believe that is the orientation. So we have a groove here, which is a groove here. So we're going to put this like this. And it looks like we need to screw these in. So it looks like it has to go underneath. And I'm guessing, yeah, that looks about right. So it needs to go in like that, right? Not like that, because the screws don't line up. And not underneath. It has to go this way around here. Okay? So we need to screw that in from the bottom. And the same on this side. So let's get those screws out and do that. And as you can already see, this is a little bit fiddly, and it's not the most fun task in the world putting some coolers on, but I think the stock one is a little bit easier to put on. But like I said, we're not going to bother with that right now. It'd be interesting to do some benchmarks with the tube. Maybe I'll do that at some point, but right now, let me just see, make sure I've got this in the right round, because yeah, it doesn't go, it only goes in one way. So it only goes in this way. It's the only way the hole lines up. So you've got this curved bit here, at least on this cooler. I'm gonna put that in there. And we're just gonna screw that in. Looks like I picked up the right screws, right. Do the same on this side. Looks like we're in. Right, okay, that's done. Now, what's the next step? The next step requires us to get the bracket. Get these plastic clips out, see what they're about. Okay, so I've somewhat deciphered the instructions. So we have an AMD plate, and on the back we have an Intel plate. So what we're going to focus on is on the AMD plate. And the pieces we need are these four metal sticks here, and we need these wider plastic brackets. These four are for Intel. You can see that on the instructions here. So what we're doing right now is, this is laid out the same way. We've got the AMD face up there, and what we need to do is put these metal poles into here, and because they were aligned in a certain position, right? So they go in there, and these parts will then slide in this way, right? To cover it. So let's do one here, and then I'll do the rest of them. So we first make sure that it goes in, and then we cover it like that, right? So it stays in. So let me do the rest of them, back in a sec. Okay, so let's get rid of these instructions and packaging, and this is how it should look. So now that is going to go on the back of the motherboard. Right, so I've got the motherboard, but I've just realized we have a back plate already here, and we have screws holding it in. So let me get a screwdriver and remove those screws and see if the bracket at the back comes away. See, sometimes you just have to learn as you build. Every build is a little bit different depending on what components you go for, what motherboard you go for, things like that. And I just realized I lost my mic. I'm hoping that you could still hear me, but let's get these screws off. Okay, that one's off. Get this one off. It's funny how all of them have lots of different ways of, different manufacturers, different coolers, different ways to mount the CPU cooler in the same, socket. It's really weird. But anyway, it is what it is. This is, by the way, the bracket we're taking off is the standard AMD mounting kit. So if we were using the built-in cooler, the Wraith cooler, it wouldn't have all these issues. So, oh, there we go. And it came away nicely. So let's get rid of that and bring that back in the picture. Now we can see that it's going to go in something like this underneath, right? It's going to go like that. So let's put the motherboard on top of that. And where is it? There it is. So we need to make sure now, this is another thing. So one thing we forgot to mention is that on the manual it did show that there is an AM4 slot and an AM3 slot, and we need to make sure that we are indeed on the correct one. So I think if we can just literally slide these along to make sure they're correct. I think they all need to be on the outside. So let's check that again and we should be good. There we go, because I'm sure I read it right, but I guess I forgot to do it, and it's another thing, real time, made a mistake. Alright, now we'll see the hard work we did with these metal poles. We're going to literally put this on top, and these screws should now be in line with those holes. And it looks like it is. We're going to find out obviously as we screw it in. So now we're going to start screwing in. No, we're not. We need to remove the plastic and put the thermal paste on. So let's do that. Okay, so I've got the Cooler Master paste that came with it. I'm not sure how good it is. I've got some MX4 lying around somewhere. So this is called Master Gel Pro. So let's remove this plastic from the base of the cooler. Oh, it's stuck down quite tightly. And what we're going to do is, there's so many different ways to apply paste, right? Which one is right? I'll tell you what I'm going to go for this time. I'm just going to go for a small dot around that size in the middle. That should be enough. The idea is just to fill any gaps in the contact. So now, making sure we've got this the right way around, I believe this is the right way around. Yeah, that looks about right. So we're going to put this CPU cooler down, lining it up with the holes. I'm looking at the screw holes, by the way. So I'm just trying to line it up. Okay. And what we're going to do now is, one corner at a time, we're going to screw these in. And even on the instruction here, just thought I'd quickly show it to you, it's got 1, 2, 3, 4. So they're doing it in a cross pattern, right? So we're going to do exactly the same thing. We're going to start from this corner, and I've immediately noticed that it's not going to be so straightforward to get this screwdriver into there. That's interesting. Let me get a different screwdriver, a slightly smaller one, but this is going to be a pain to install already. But you can see from this side that I can't actually reach the screw head. So let me get another screwdriver. Okay, the best way to describe this is, it's very awkward. So because these screws are so close to the heatsink, it's almost impossible to get the screwdriver correctly in there. So what I've managed to do, I've got this corner, the back corner here in, just about. And then I've also got this corner in. So we're going to do that whole cross motion. So let's try and do this one together now on camera. And it's really not very straightforward, but you can see I'm struggling here. So I'm really having to force this to go in. So we've got it in a little bit now. There we go. And we're going to do the same thing again. So I need to line up that screw. And that looks about right there. Wish I had a second camera set up now so that you could see this, how this is working out. But there we go, all the 4 screws, we've done one, more or less like 1 and a bit turns. So we're just going to carry on now. We're going to go with number 1, screw it down a bit, then go to number 2, screw it down a bit, then go to number 3, and we're just going to keep going like 1.5 to 2 turns each, just to allow for even pressure across the CPU, right? Hold on, yeah, that's correct. So 1, 2, 3, 4. So let me just keep doing that until we get all the way down. Okay, so that's finally in. So you can just about see here, you see where those screws are? It doesn't tighten anymore. It gets to a point where it doesn't tighten anymore. So that looks like, we've definitely got contact there with the CPU. It was a pain. It's not the easiest cooler in the world to install, I'm gonna say that. So we haven't removed the RAM yet. Let's see if we can actually get this cooler fan on without removing the RAM. Oh, there we go. So it fits perfectly. So there we go, that's done. And now the only thing we need to do now is locate the fan header. So that should be CPU fan, which I believe is this one on the top left corner here. So because it's at the top, let's just get this back off so that I can get the cable on the other side to keep the cables as neat as possible. Let's just see how that looks. How's that? That's fine. And here's the RAM clearance I was talking about. These, by the way, these fins on this cooler are quite sharp, so be careful if you do get it. So we've got nice RAM clearance there, which is good. So that's that done. And now, oopsie daisy, got it stuck somewhere. Another real life problem that can happen. There we go. So now you line up this notch on the fan header with the motherboard. There's three, because it's made for 3-pin and 4-pin connectors. And that's it, we're in, we're done. So that was the hardest part, believe it or not, except for putting the motherboard into the case. I think that would probably be a little bit easier than this still, but that's the hardest part of the build done. So this is more or less our computer built, which is not bad at all. So now let's get the case and continue. Okay, so let's get to the case and the power supply. And I'm filming back in the kitchen again because it's later in the day, lost the light, and I think this angle is better for what we're about to do here anyway. So first thing is we need to get the power supply into the case, and the only way we're going to be able to do that, if I remember correctly, is I need to remove the bottom panel as well so we can access the space for the power supply. So let me just get that off. Same before, I forgot to remove this panel the first time, or probably just thought we could slide the power supply in. I forgot that we had to go in from the back, or from underneath rather. So that's off, and now straight away we can see that it will be much easier to get the power supply in now. So let's take the power supply and put it underneath, and there we go. This is going to be the hard bit. With smaller cases and with non-modular power supplies, we're going to have the fun and games with all of these lovely cables. And we're not going to worry too much about the cable management, but you can already see how annoying this is going to be. Right, so the power supply is in, and what I've done, just so that you can see this, I'm going to just show it to you quickly from above. The fan on the power supply is underneath the case. It's not here, right? It's because we want to avoid contact with this part of the case. Sorry, we don't want to have the air blowing onto the motherboard. Right, so that's in. And let me just get the screws and put that back, screw it into the case. Right, I've got the screws that came with the power supply, and I'm just gonna line up the holes at the back so you can see these holes here. So there's multiple holes because it's made for us to install in multiple orientations. So we're just going to start with one corner so we can see this hole right here. Just about, I hope that you can see them, but it's very hard to see on camera anyway. You can see, but you get the idea. So there's 4 screw holes, and we're going to put 4 screws to the back of the power supply into the case. Oh, missed the line there. Okay, let's try one of the other holes. I think that's not lined up at the moment, so, oh, that one worked. Can we see the other ones in line now? No, let's loosen them a little bit. So this is what happens, but sometimes with screws you have to make sure you don't tighten things all the way in. Otherwise, it's a bit hard to get the screws in sometimes. But that was that. Sure, everyone's done a better job than I have at that, but it's in. That's the most important thing, is it's now in, right? Okay, so with the power supply in, I'll just turn the case around, and I just want to quickly show you something. If I move this the other way, you should be able to see in here, this case has actually got some standoffs that are built into the case. Now sometimes you may have little studs or screws that you will actually have to screw in yourself based on the size of the motherboard and the case. In this case, because we only have an ITX motherboard, they've decided to pre-install standoffs as part of the manufacturing process, which makes life a lot easier for us. So that's the only 4 screws we need, and we're going to use those to screw the motherboard in. But let me stand this back up and let me get the board and let's see how it fits in. Okay, so I've got the board, and if you remember, when installing the cooler I had to remove the drive at the bottom because the board wasn't level. So I have reinstalled that SSD at the bottom. Now the biggest problem is the thickness of that SSD. You see that? The thickness is going to maybe stop us installing this the way we want, and I might have to go with the other drive, and it was something I anticipated that might happen, but let's find out. So I'm going to put this into the case, literally. That's the good thing about this case, because it's open from everywhere, and we're going to line up those standoffs, and yeah, that drive is not going to let us work with this case, so I'm going to have to go and source another drive, unfortunately. You can just about see it's just not going down enough, so that means that the SSD is in the way. So I think what we're going to do for now, let's take this out. I'm going to remove that SSD, and I think what I will do, I will actually, let's put this here. I think the best thing here is going to be to remove the SSD. So we're just going to take that one screw out. Take this one screw out. And I'm going to put the SSD screw back into the slot. Okay, that's done. And I think what we might have to do for now, because I don't have a spare drive, and ultimately you'd get to experience the entire build process with this slot at the front. So let's get to it. So we just have 2 screws here and here. Now what this means is I would actually lose my heatsink fan, so this is not a good idea. If you're building with this board, don't use the drive that I'm using. Make sure you just get a normal drive without the heatsink. And you see now why it's important, because clearly we can have issues going forward without the heatsink fan, because see, we're going to remove that fan now. The fan's gone, so I'm going to remove this fan connector, so just be careful with that. There's a fan connector right here, and that should just pull out, I believe. Okay, rather than take the fan off, I've decided I'll remove the SSD screw from there, like from the back earlier, and I'm going to put this drive in here anyway. Maybe I should get rid of the screwdriver and put that drive in, and let's see what sort of clearance we have once the drive is in. Maybe, is that in? Will that actually stay? I have to try this now, because it looks like it might just stay. So where's the SSD screw? There's the SSD screw, and we can just about see it from the back there, so that's quite cool. So alright, the SSD is definitely in, and now if these screws get in, I think they might, you know. Wouldn't try this at home, guys, but you know, sometimes it's fun to do stuff like this, and I think it's actually fit. So it looks like we'll be able to complete our PC build after all with the same drive, and that's really amazing that it actually fit with the heatsink. How lucky was that? Let me see if it, I'm not going to force it. As soon as it's tightened, I'm going to stop, but it actually looks like it's gone all the way in. Amazing. How cool is that? Right, let's get this in the case. Right, so now obviously with the SSD gone, we should have no problems whatsoever lining up those screw holes, and indeed they do. So you can just about see here, if I just push that in a little bit, make sure the back plate lines up. And that's the nice thing about having a built-in back plate. It's much easier than trying to fit the other style where you put the plate in first and then fiddle about with it. Maybe that would have been more practical for a build like this, because I'm trying to do a detailed build, but it's in now, and you can see the screw holes are nicely lined up. So we're going to get the correct screws and screw that back in. Okay, just quickly show you from the back as well. There's a plate, it's nicely lined up at the back, so just make sure that's lined up. There's no like proper visible gaps or anything, and it should be all in line. And if I just show you one more time from here, from a slightly higher angle, we should be able to see there the screw holes all lined up as well. Okay, so let me get the correct screws and we'll screw that in. So one issue I've noticed, which we usually have, is we have a bag of screws like this, right? And we don't know which screws are for this standoff. And I think it's not even labeled, if I remember correctly. I don't think it's labeled. So we're gonna have to check now. What's the risk with this is that some of these standoffs in some cases use thin thread screws, and the other ones use a slightly thicker thread screw. So let me see if I can find out which one's supposed to go in there. So in the end, I found these round-headed screws with the thick thread that seem to fit fine. So I've put 3 of them in. Just need to put 1 more in. I've been having a bit of fun because it's not really very magnetic. I think. Oh, we got it. Okay, that's it. So all 4 screws are in. Make sure they're all tightened. And that's it. So the motherboard is securely in place. Right, so what I've done now is I've got rid of all these cables. I've taken them all out this bottom hole for now, just to get them out of the way. And I've only got the 2 that I need for now to connect the processor and the motherboard. So this is the 24-pin connector we showed earlier, and this is the 8-pin CPU connector. So where are we going to connect those? Right, so the first one is going to go right here. Into the motherboard. That's the 24-pin connector. I'm just going to connect it literally like that. You might have to hold that 4 pins together because some of them in some power supplies, especially this one, I'm guessing the more budget ones would have the same issue. The 4th pin, the 4 pins doesn't necessarily stick nicely to that connector. So that's in now, and you can see that it's securely in. Let me try and show you from that angle. You can see just about, I hope. I think we're going to have some serious focusing issues here, but it's connected there, right? It's just about there. Maybe if I turn this around you can see it better. There we go, should have done that before. So there's a 24-pin connector, and this side here we have the 8-pin CPU connector right there. Now I wish I had connected that first, and this is the thing about planning your build. Sometimes easier when you're actually doing the build to try and connect those cables before putting the motherboard into its place. It just makes it that little bit easier once everything's in. So let's see if we can just squeeze that 8-pin. So again, see, I'm trying to line them up. Same issue, can't line them up nicely. Let me see if I can clip them together somehow. Nope, they just don't want to go together. Right, okay, anyway, it shouldn't be too much of a big deal because we can probably stick them in separately as it is. So we're just going to put this right here. I think it might be very dark at this time, but I'm going to try and show that to you. So we've got the 2 lined up there. Just going to line it up and push it in. Okay, that wasn't too bad, right? I probably should have routed around the back somewhere, but right now I'm eager to see if this thing works. So this is not the best cable management. I should have probably routed it through the back of the hard drive cages there or something, but it doesn't matter. It's in, and it looks okay so far. So once we connected some power switches, we'll be able to check if this machine turns on. So we have that front panel header. It's nicely labeled over there. I think you can just about make that out, right? And we're going to have to put at least the power one on. Where's that front panel header? To make this machine bootable. I think I might have to leave cable management for another video, but for now my main concern is just to get that power switch. So we look for the power switch. So there's power switch upside down, but that's the one. And we need to connect this to the corresponding jumper on the motherboard. Now, usually I would recommend just look at your motherboard manual and see what it says. That would be the easiest way to work out which one is the power switch. And we're just going to connect the 2 pins onto the corresponding slot on the motherboard. I can't really show you in there, it's too cramped now, but let me just plug that in. Okay, the power switch is in, and then we have this front audio connector, right? So there's a corresponding header right there. It's the white one there. So the pins are actually matching the layout. So all we have to do is line that up and push it in. Okay, that one's in. And the one more thing that I want to plug in is this fan. So there's a 200mm fan at the front of this case. So I'd like that to be connected. And I do have some additional fans for the case to exhaust, but we're not going to install them right now. So that is going to go onto system fan 1. At least for now it is. And there's a 3-pin connector. You see, before we had a 4-pin connector. This time we've got a 3-pin connector. Right? Is that focusing or not? There we go, just about. Okay, so let's plug that in. So the front fan header is also in. Now what I'm going to do is try and push all of these cables in here for now, right? Because this is going to take some serious cable management. And we've got the USB ports. Let's plug the USB ports in. So this is for the USB ports. We'll bring that through here as well. And there is one large header port right here. That's the one right there. Not sure if you can see in there, but that will take the USB 3 header, and that's usually a blue plug like that. So plug that in, and that will be for these 3 ports. There's 2 ports at the front. Make sure it's lined up. There is a notch, so you can't get it wrong. And that is also in. So now I think all the main cables that we need are now plugged in. So what we will do is just, well, I guess I shouldn't, yeah, that's fine, that's fine. Is that going to be all right? It should be all right. Okay, so let's put all of this stuff, squeeze it in here for now, because we don't care too much about the cable management. Once it's closed up, it will look fine. But yeah, I'm sure there's a better way to manage this cable. Let me just reroute this audio cable from here, because it might just get in the way of the panel. So there we go, that's that. The cables are very long, and this is going to be a pain to cable manage, right, in such a small space. But I'm sure we can get there, and I still need to put some drives in here because I plan to use this for a NAS or something. So I've got 2 spinning discs that can fit on the other side. It's going to be interesting to see how the cable management works out in the long run, but for now, that's it. So, alright, so that's it. So the PC is now ready. Like I said, it's not the cleanest build in the world right now, but that is it. There's our machine complete. Behind that mess is a PC. PC looks non-existent behind the cables. So I managed to find my camera light, and I think it would have been better to use this in the beginning. I've done a little bit of cable management. I didn't want to spend too much time on it. I didn't want to waste time on the camera, but you can see it a little better inside now. And from when we look from the top, the cables look a little bit neater. Not much neater, but I also managed to find out that there is plenty of space between the side of the case and the cables here, so that we can close the case without any issue. So I've rerouted all the cables back outside and tied some of them together on the inside. So what I'd like to do now is, I've got these 80mm fans. These are 4-pin PWM fans, so they have a bit more control through the BIOS about how fast they spin and according to what they should spin. And then we have the current fan, which is connected here, is DC 3-pin, right? So that can be controlled by current. We're not going to go too much into those details right now, but there's only one fan header for the case fan. So I've got 2 of these fans, one here and one here, and my plan is to use all of them from that one fan header. Now, obviously the thing is that we're going to be using 4-pin and 3-pin fans, so I'll worry about how to set that up in the BIOS later. But for now, we're going to put these 2 fans, connect them together, and this fan with a splitter. Now this PST fan from Arctic, PST is, I don't think you've read it, is power sharing technology. So they come with a connector to daisy chain the fans already. But obviously once we get to the end of the daisy chain, we're going to have to split with this one. So let's start by opening these fans up. Okay, so let's just get rid of one of them for now. Let's do a quick unboxing of this. Nothing too exciting, of course. Got some fan screws in there. and there is the fan, right? So this is the 8cm fan. Wish I could have got white ones, but it was all that was available at the time, so I just got them for now. And there's too much black in the case for me to worry about things like that anyway. So here I was talking about the PST, and the PST means that there's a daisy chain cable already there. So if you don't have a daisy chain cable already on the fan, you can obviously use a fan. I've got a double fan splitter here. You can use a triple fan splitter. So all we're gonna do now is the flow of the air, I believe, is usually in this direction. So this is the front of the fan blows air this way. So we're gonna put the case fans in like this, right? And they will both help extract the hot air from the case. I don't think it's gonna make too much difference here in this setup, but we're literally gonna just put two of them there next to each other. So let's get those screws out. I'll put the first one in, just a couple of screws so you can see how the setup is, and then I'll just screw the other one off camera, because I know this video is already very long, and I appreciate all of you staying this much time, if you're still watching, of course. And I don't mind if you switch between, you know, which section you like, or what's easy for you to follow, or maybe if you want to just see how to install the H410R, for example, that's fine. That's the whole purpose of this video, just try and make it useful for everyone. So first thing I'm going to do is make sure that my cables are to this side, because I'm going to try and daisy chain on this side, and I'm just going to line one of the holes up at the back, and I'm not going to screw all the way in. Where's that hole gone? Right, there it is. Just going to try and hold that in place. I think the screw's gone just a little bit bent there. By the way, in the comments, if you don't mind, let me know if this light is actually better than not using the light, because it's so hard to record like this. Wish I had a studio sometimes, but we'll get there at some point. Let me just readjust the camera just a little bit. So one screw is in, and you can see there, we've got the camera nicely lined up there, and we have our cable which is already routed around like this. So let me put the other fan next to it. So let's quickly open that up. And just line it up next to it so we can make sure that our cable management is going to be as we are expecting. So we're going to line this one up here, and we're going to try and connect the cables together without getting in the way. So let's try and do that if we can. Okay, so this fan is going to go like that, and what we want to do, and we can't actually get access to that cable, so I'm going to have to wire that first. So let's just plug that in like that and see if we can get past with both of the fans in. And that looks good. And then what we will do, we'll use this connector to connect to the fan header, the splitter rather, right? So let me screw all that in and let's see how it looks. Right, so both of those fans are in. You can probably see them there. It's almost amazingly accidental cable management, just one wire at the top there. So now what we're going to do is connect one of our, now if you're using a splitter, by the way, you'll see that one of them only has 3 pins and one has 4. So the one with the signal is going to be the one with the 4 pins. I'm not sure if that's focusing well, but we want to connect the one with the 4 pins to this side here, right? So I'm going to connect that 4-pin fan header here, and I'm going to route it down the bottom here. And then what I'm going to do is take this fan out for now and plug it into the other side. So we're going to plug that one into here. So now we just have to connect this one cable into the motherboard. So we ended up with an extra long cable. This is what I don't like about extension cables and things. But anyway, we don't really have much of a choice here. So now we're going to plug this fan header, this one connection from all 3 fans, into that connector there. Okay, so it looks like an absolute mess from this side, but I think from the top it won't be so bad. Okay, I think the more logical thing to do before worrying about how the cables look inside the case is to make sure the PC actually works, because the build is now complete. So I've got my keyboard, monitor, mouse, everything set up, and we're going to press the power button here on the side. Just make sure my power supply button, yep, it's on, all the power switches are on, and we're going to hit the power button and hope that it turns on. Now I'm going to repeatedly press the delete key because it's the one that we would use to get into the BIOS. Because the first thing that normally happens when you set up the PC is that you will need to like enable XMP and things like that to make sure your memory runs at the right speed. But usually what happens when you boot the PC for the first time, you'll be presented with a screen, might be presented with a screen depending on what motherboard and what BIOS you're using, to say, oh, your BIOS has been reset, or CPU has changed, or RAM has changed, or something like that, and you'll need to go into your BIOS and make sure all of the settings are correct. So if straight off the bat, everything looks like it's working absolutely fine. You can see that our SN850 hard disk is here. Looks like I installed Windows at some point on that. Maybe it wasn't direct from the PS5 like I mentioned before. Anyway, that's a waste of time. So it says here 2400 megahertz and it's XMP disabled. So if I click on XMP, it says now DDR4 3200 16 18 18 36, which matches the timings and specifications of the RAM for my system. So now I can just save and exit, and now I need to install Windows. Because we're not going to do that right now at this stage in the build, our build is successful and we can see inside the case here. Let me just move over to the case. You can see everything is on. Got some fancy lights there at the bottom of the motherboard, got the RAM lights, everything is working perfectly fine. And from the top, as you can see, like I was saying before, there's not really much cable interruption. So when we put the glass panel back on, it will look nice. So I think we're done. I mean, we can more or less conclude the build here. What I will do is let me just put the glass panels back on and see how it looks when it's closed. Okay, so I've got all the windows back on, and I've got all the panels back on. Got the computer on its side so that you can see indeed that it really doesn't look very bad from the top. The cables are more all around the sides, so it's not that bad when you look at the case from the top. Looks relatively clean, reasonably clean. It's good enough. Again, some of those cables, that USB 3 cable, they're just way too long to do something within this case. I'm sure you can do something creative to hide as much of the cables as possible. And obviously from the front, it's going to look clean anyway. And we can still see that fan light through the front there. Let's just turn it to the side and see how it looks. And there we go. Looks like an absolute mess through that mesh. But anyway, the main thing is that our build is complete. And I'm happy with it. I'll play about with it now, install Windows and things like that. And I'm hoping that if it's the first time you're building a PC, or if there's some questions you have about ITX builds, or if I've missed something, let me know. I hope it's been helpful if it's the first time you're building a PC. And again, if you are doing that, feel free to ask the questions and I will try and help where I can. In the meantime, thank you for watching. I know it's been a long video. Please do feel free to like and subscribe, and I'll see you in the next one.